Okay, so yeah, I think just to summarize, I think what we learned in the last session is primarily about AWS VPC. Uh, I think just a quick recap of what we learned last week, so that we'll continue on the similar concept from where we left. So, so I just want to give a quick recap. So yeah, primarily what we saw what is VPC. Primarily to help you to create an isolated network in AWS cloud, and you can form your own virtual network with this. Also, we saw various use cases, and we also quickly covered about the regions and availability zones, um, and also generally why regions are, what are the considerations for a region, generally to select a region which is closer to you. And also you should keep in mind that not all regions will have all the services. Cost will vary from region to region, and other legal complaints and other things. Then we also saw about the VPC scope, where by default VPC will span across availability zones. But if you want, there's a question in the call that what is the solution if you have to spread across regions? The answer is VPC has a concept called VPC peering, which we'll be going through today. So that will be helpful to give the inter-region scope for VPCs. I mean, you want to transfer data across regions between two VPCs, and then yeah, so VPC pairing with inter-region is an option to be considered, which we'll cover today. So yeah, so this is typically an architecture where a cloud in that region and under that availability zones, where VPC will span across availability zones, uh, and there will be subnets inside each availability zone. But subnets are restricted to availability zones, and under that you'll have EC2 instances. The subnet could be public subnet or a private subnet. So, and this is default VPC option is also available. So if you're not giving any custom VPC requirements like how we did in the last demo, by default, if you don't want to enter all these details, VPC details, then you can directly go with the default setup, which when you create a EC2 instance, yeah, so we'll have the default options. We can select default and then proceed. So you don't have to define all this custom setup. But generally for enterprise setup, yeah, you will go with custom setup. You will not go with default generally because of security reasons and because your every requirement will be different. And we also saw about the various components of VPC, and especially the component like public subnet, private subnet, and also where that is a boundary of your range of IP addresses, and route table, where you generally it's something like a firewall where you will define set of rules. Uh, that's where basically you tell which traffic should be allowed and which shouldn't be allowed, and which IP range should be considered to access the other range. So all those things, rules, you will define it here. And internet gateway is a component which will provide internet to your VPC. Uh, and then NAT gateway is what we're going to see today. So this is primarily this will allow instances in private subnet primarily to communicate to the internet. So typical scenario is that generally we discuss that the public subnet will have an internet gateway tied up. So that's why you in public subnet you get internet. Uh, but if you but in a private subnet generally there'll not be internet. That's why it's called private. So you don't have any internet. So but there could be scenarios where you might need internet temporarily. For example, you want to do a database. Let's say if the database is installed in this private subnet, and you want to do a patch upgrade of the database. So temporarily you need internet for 1 hour in the private subnet. Then in that case you need NAT gateway. So yeah, so basically NAT gateway will allow instances in the private subnet. That is a keyword. So private subnet to communicate to the internet. But where does this NAT gateway reside? It will not be inside private subnet, but it will be inside the public subnet. So I think we will show it in a demo, but you will understand it. But generally, this NAT gateway will give access to internet to private, but the location where this NAT gateway will be situated is public subnet, because this is where internet gateway is there. So that's why NAT gateway also should be in the public subnet. Yeah, the location is in public subnet, but it will help you to get internet access to private.
Basically, the private machines will tunnel to the public one through that.
Yeah, exactly. Yeah. So that is what we're going to see in our demo today. Um, And yeah, we'll just come back to that. So then the other item is that VPC endpoint. Generally, yeah, this VPC endpoint is private. Primarily help you to privately connect your VPC to other AWS resources which are not in your VPC, for example. This is primarily a scenario where let's say, yeah, let's imagine. I think this is a demo that we saw, but this is our VPC boundary. Okay, so this is our VPC boundary, and let's say outside there is here, so outside this range there is a another AWS resource. Okay, another EC2, for example, and if another resource want to talk to this boundary EC2, this bounded EC2, so in that case you need something called VPC endpoint. Okay, so what does that mean is, like, you can privately connect to your VPC or other resources, uh, and this is privately connect is the keyword. What it means is it will not have internet. So privately connect here also private. When I say don't no internet, so without internet, so two VPCs can talk, for example, using VPC endpoint. So that is what is VPC endpoint. I mean, from the name itself, it is endpoint. So it gives a tunnel kind of a scenario where two VPCs can talk to each other without internet. So that is the VPC endpoint. I think this is a new latest entry which has come, which is primarily kind of almost replacing this NatGateway in a sense. So this is more even this is the latest entry in the AWS products. So and very important thing is it uses private link. So that this is something a feature that was introduced recently by AWS where they want everything to be connected without internet. So that was their goal. So I mean, the idea is if internet is there, then it is prone to security issues. So, but as long as if all the products can communicate to each other without internet gateway, then it is more secure. So that is the idea. So VPC endpoint is meant for that scenario. But of course, these NAT gateways also will give internet. But only thing is, these NAT gateways will talk via internet. So, but this guy will not talk via internet. It will not. He will talk without internet. So that is the difference. Okay. So yeah. So this is what I think. I think this is an enhanced version of this diagram. So is this. So if you look at there will be an AWS network. Uh, and basically what you're going to see is an NAT gateway. Okay, so as I said, like NAT gateway, as I explained before, this NAT gateway will be in the public subnet. So if you look at this is AWS and this is VPC boundary. The VPC boundary is having an IP address of 0.0./16. So this is the VPC range, IP address range for this VPC boundary. Inside that there's a public subnet and there's a private subnet. So private subnet will not have internet. Public subnet will have an internet because it is connected to internet gateway. So this internet gateway is one which is giving access to internet to public subnet, whereas private will not have internet facility. But for example, let's say the database instances are database servers are there in the EC2 machines here. Install some database server like Oracle or some other component on the EC2 machine in the private subnet, and let's say this guy needs an internet temporarily, then he will talk to NAT gateway, uh, which is in public subnet, and from there he will get access to internet temporarily. So that is what the purpose of this NAT gateway. So the in the route table, this is the entry of the route table. If you remember in the last session, we added a few entries to the route table. So generally for this public subnet, the green ones, if you see here, so this is you will how will you connect the internet gateway and public subnet with this route table? Like you tell that 0.0.0.0, which means all IPs can talk to IGW, internet gateway. So if you define that, then this guy will be having an internet facility. So that is how you link this box public subnet to this internet gateway. So basically this entry is what you make, so that links these two guys actually to get the internet. Um, Similarly, for the database side, so here for a NatGateway scenario, instead of IGW here, you should tell NatGateway. So this NatGateway is this basically. So this NatGateway entry, if you make, then this guy will also get an internet temporarily. So basically, summary is the route table is the critical. Even though you have many components, the rules that you define here makes that connection between the various components. So for any questions here? Okay. So let's. I think we are more or less will be doing the. I think I got feedback from a couple of guys. I mean, at least from Praganya and Lakshmi, that I think last session, if a recap of that would help. So I think today it is more or less the recap of the practical scenarios that we saw in the last demo. I think we are going to create as from scratch. We're going to create a VPC. Yeah, we are going to create a public subnet, and we are going to create a NAT gateway and associate all these things. So we'll do all these things in this demo.
Yeah.
Yeah, so that way it will kind of a recap for you. So with that, I'm going to the demo section.
Yeah. So Shyam,
Yeah.
one thing.
Yeah.
You are doing all this on the web browser using this what do you call the portal, right?
Portal. Yeah, correct.
So is there a API to do this programmatically? Like
Yeah.
let's say
Yeah, there are three levels are there. One is usually Java or Python or something. They have an API, and we could do everything through that. But it is you have to write lots of. It's like a programming, right? Fully. That is there. But the other way is the cloud formation. They have the template-based thing, so that infrastructure as code automation using the AWS cloud formation tool called cloud formation. Now they have introduced one more layer called CDK, Cloud Development Kit. Okay, like SDK, CDK. So CDK will generate cloud formation because, for example, whatever Shyam is trying to do will take at least 700, 800 lines of code in cloud formation. It is very verbose because you have to define everything. You have to define nitty-gritties of what you want to do. So they are coming out with another layer called the CDK. So it is evolving. That is the power of AWS. You could able to create everything through your code. Your compute is a code, network is a code, security is a code, services is a code, everything is a code.
No, so the thing is, it goes back to like if I have a diagrammatic representation, I can say, okay, this is what I want. Is that the way CDK is evolving, or is it?
The diagrammatic thing now CDK it gives if you know Java or if you know Python or something, you just enter only the for example the parametric way things rather than the plumbing things. The cloud formation is a good tool, but you have to put lots of plumbing things along with it. But it's remove the plumbing so that you could just parameterize what you want to do for when you want to create, for example, VPC, NAT gateway, internet gateway, right? Security group. So when you try to do those things, it will be like probably 15 to 20 lines of code in the CDK. Still, it's the code. You need to know the syntax, but it is much easier to understand what is being generating, rather than looking at 800 lines of code.
Okay, so from
But still, there is no UI, man. There is no UI kind of a thing. It is not. Yeah. Those days are gone.
It's not like rational rows where you can draw.
Yeah, those days are gone.
The CDK then probably is more useful for the marketplace products, so they can develop the applications which can create these kind of the AWS infrastructure.
Yeah, they could also do that. Yeah, anybody can. It's for even for customers also. It's for you and me. That wrapper is available. They introduced only last year. It is getting momentum. It doesn't have all the APIs yet for all the services, but they're expanding every month. Yes, it is catching up.
So it's a dumb question. So if you can do everything through the AWS portal through these kind of the menu-driven options, and in the world of consultants like you and me, where does the coding come into picture?
Yeah, that is because nowadays there is a huge paradigm shift. Okay, I learned it only last year. People doesn't want you to go to a portal and try to do click and see and press and do it, because they want to do not one environment, they want to do hundreds of environments. They want to make sure this environment and that environment are exactly the same. If I give it to you, how can you make sure? You could have made a human error, right? So that is why the automation is making sure it's all being governed, it's all being tested once, it's being automated. Once it's all automated, infrastructure is nothing but automation nowadays. Just if you have a set of code, if you want to create anything, just execute it. It's going to execute it like a 5-10 minutes. You get the whole thing for you. And since right now, yeah, Sham is teaching only 5 or 6 concepts, but in reality, it will be like 500 of those things put together. So human error is huge, paramount, and also people doesn't want to invest time on consultant time. They want consultants to automate, so that business guys can just click it and make it work. Operations team will take it over.
So, but the problem in the coding, like any other application development, is in this infrastructure. If you make an error or a problem in your code, and this is going to be pretty expensive because you're creating infrastructure, you're modifying it, and there
Yeah,
is validation taking place.
you have to validate. That is the power of the automation. Once the so what they usually do is not only the creation is the automation, even testing is also part of the automation. So you could always say these are the things what I expected out of the service. So you provide the inputs and see if all your touch points as expected outputs are coming on the security level, on the network level, on the application level. Because everything is code now. Infrastructure, network, security, compute, everything is code. You could able to test every aspect of it. That is the power.
Yeah, so that's the new career, right? DevOps and infrastructure as code. Actually, those are the two things which operations as a development team or like development is handling the infrastructure. So they come up with IaaC, which is infrastructure as a code. Actually, basically, you specify some kind of template, and that's it. Like the automation takes it and creates the infrastructure within no time, and that's the power of all this APIs and other things. That's
Yeah.
where
And
we
then
are going.
yeah, the next big thing is the multi-cloud. So if you use some tools like Terraform and so on, just to just to you parameterize some of your things, because between the AWS and Google, almost similar except some of the parameters. So if that is parameterized outside, you could just run the same infrastructure as code and just change a different parameter file. That's it. So that is the power. Hybrid cloud also.
Yeah. Yeah, I think hybrid cloud is what most of the enterprises are going towards now. I think they don't want to stick to just one cloud, and that's the reason everyone is moving towards open source products, and that is primarily the reason why AWS is introducing all the open source commercial support into AWS. For example, they added a lot of open source products like Elastic Cache, and they added Cassandra DB, which is an open source DB, and all the open source databases are now inside, like Postgres and MySQL, and all those open source databases are also brought inside. So yeah, I think no one want at least people who have a multi-cloud as their vision. So they want to stick to open source, and also they're looking for commercial support, and that's where AWS is giving them now. So they get the benefit of both. So MySQL will work the same whether it's in AWS or Google or whatever. So other clouds. So yeah. So that is the main reason, and also they want to move this. This compute and networking also they want to move towards open source because all these are proprietary of AWS now. But that's where this Kubernetes is coming into market. I think it is already so become so popular that that every all the vendors now started giving the flavor of Kubernetes. So that brings everything in under open source category. Basic infrastructure, if you have, you can have the software, you have the compute, you have the networking, you have the all the other resources. You get it in Kubernetes. Yeah, I think we'll come to Kubernetes setup. I think sometime in our following sessions. But I think that I didn't touch up in the compute section. Reason being, you should know the basics. I think this. I mean, just I want to start from basics. So EC2 is a starting point. So and from exam point of view, this is important. So that's the reason. Yeah, I think I restricted to EC2. But I think in compute there are other things also which you need to complete. Yeah.
Shyam, just a quick question at this point. Probably
Yeah.
it might be a deviation. Sorry about that. Regarding the open source, AWS is supporting is fine. But if there is a problem once in implementation, when it goes to production, and who will be responsible for such open source problems and issues? Because there is no such owner for an open source, right? So in
No.
that case, who will be responsible, or how will it be addressed?
Yeah, I think
Amazon definitely is not responsible. So in that
No,
case, how?
no. Amazon has managed tools like RDS, right?
Okay.
So RDS is nothing but they take the open source and they host it, and you pay them and they maintain the whole thing for you. So that is the paradigm shift nowadays, and it's
Okay.
you are paying very nominal amount for that.
Okay.
So the main open source is also being used internally. Amazon Stack, if you see, mostly everything is open source, but they do the maintenance and provide the managed service. That's it.
Okay. Okay. Yeah. Thanks.
yeah. So yeah, just summarize. I think what Srini told. I think I just came to RDS. If you look at here, you get all the open source flavors. These all, for example, MySQL, MariaDB, Postgres. These at least these three are open source implementations. So here they provide managed services for this. So which means anything on MySQL, AWS is responsible here at least for an RDS case. So MySQL is responsible to manage the installation, the patch upgrade, and everything. My AWS is responsible. So you'll be just paying for the usage, but yeah. So basically the security aspect, everything is taken care there. Okay. So yeah, just I think we'll come back to this. I think to answer, I think there are other softwares also. For example, Elastic Beanstalk. So not Elastic Beanstalk. Elastic Cache. Sorry, Elastic Cache. This is also an open source implementation, which is now they are brought into RDS as it's an open source solution, but it is now supported by AWS. So like a lot of open sources are coming inside AWS now, and it is coming as a managed service. Yeah, I think let's come back to our version. So yeah, I think what we're discussing is primarily to look at implementing this. So what we're going to do is now we're going to create a VPC. We're going to create a public subnet, private subnet, this internet gateway, and link these two with this routing table, and also create a NatGateway, link it using to the private subnet, and then we will basically try to see whether by without making this entry, internet won't be there, but once you make this entry, internet will be there for this. So that is what we're going to see. So um, yeah, with that we'll start. What I did is I just cleaned up all my resources, so it is primarily clean. I'm using Northern Virginia as my region. So I'm going to first the idea, maybe just to summarize, maybe I'll show the steps which I'm going to create. So I think it is something similar to what we saw, and also I'll show it with the PPT so you understand this better. So what I'm going to do is I will create a VPC, which is the outer layer first, and after that I will create two subnets, the public subnet and the private subnet, and then followed by that I will create an internet gateway. It is just I created, but I have not associated that, so that which I will do it in the following step. Initially it will be in detached state, and then we will make it attached. Then I will create two route tables. So this router is where you define this configuration. So I will create two routes. One is a public route and a private route. So and then that's where then you will associate this, make this link. You in the route you go and associate this internet gateway, so that these two are connected. This public subnet and this internet gateway is connected by making an entry here, this route. Similarly, same thing for private subnet as well. So you go here and then make an entry in this private finally. So and then what with this now all these boxes are done. Then after that, I will go inside each subnet and will create an EC2 here, VM here, a VM here, and then I will try to connect. I mean, primarily here you will not be able to get internet, but once you add this entry, you will get the internet here. So that is what we're going to see now. Okay, so yeah, so first I before this I just cleaned all the things. So you see all the entries as empty. So I'm going to VPC now. First thing is to create a VPC, the outer box primarily. Your VPCs. Go to create VPC. Uh, Here I can give any name. I mean, I'm keeping this as a reference so that I can copy paste it. No need to type it. So here, yeah. If you see this diagram again, this outer VPC we're giving the range as 10.0.0.16, and in the subnets we are going to give this as /24. Okay. So that is so this. So we are not using IPv6. It's also supported, but yeah, we are using IPv4. Create. So we created a VPC. Now let's go to subnets. Let's create a public subnet. This name can be anything, but just for easy reference, I'm giving this. Oh, sorry. VPC is something which we created before, so it automatically pops up. So this region, it's up to us. I'm just giving. I can select any. Northern Virginia has 6 regions, so 6 availability zones. I'm just selecting East 1A. Yeah, here is where I need to give the range. I'm giving /24. /16 is like superset. In that I'm splitting that /16 into 2, /24 and /24, like 0.1 and 1.0. So just to differentiate a public and private. So create. So this is done. And then I'm creating a private subnet now. I'm just making it fast so that it's more or less what we saw last time. If you want me to explain, let me know. Internet gateway. I'm going to go to internet gateway, create internet gateway. It can be any name here. So far we created VPC, 2 subnets, and internet gateway. But everything is independent. We need to link. We're not linked them. So this is where I'm now linking the first thing where I'm trying to attach this internet gateway to VPC. Attach. So VPC and internet gateway are linked. Now we should do the same setting in route tables. Now we should create the route tables. So there will be by default when you create a VPC, there will be default route table will be created. We can use this, for example, as a public route for now. And here, yeah, so you can also create another route, private route. So now, so 2 routes are there, one for public and one for private. So this is where you do the linking. First we'll do the public. So here there is no association at this point. This is where now I'm associating a route table with the subnet. So whatever the route table that I created, I'm linking that with the subnets which I created in the previous step. So public route to public subnet and private route to private subnet. So I'm doing the public first. So this is public. So I'm taking the public we make the linking, save. Similarly, go here, private, private. So, so that linking is done. Now, similarly, so basically these two are linked. So now, similarly, we should go to the root, and here you should tell your primary your subnet association to the public root. So that's what you will do here. So you will associate. If you click here, add root. I'm telling this is being 1 minute. I want to see whether it's a public or private. Okay, this is this route management. I want to do it for public. Where this being a public, I'm adding a rule here to allow all the traffic. When I say all, it is like 0.0. And here is where I'm doing that link. If you see this diagram, I'm I've selected a public route, and in that I'm adding this entry now. So 0.0.0 and then IGW Internet Gateway. So the Internet Gateway, basically, so that this subnet will get internet access. So done. So private, I don't want to do this because I want that I should not have access to internet. So I'm not doing in private. So but yeah, it is just want to ensure that in subnet association we did that. Okay. So that's all. So basically, so with that, if you look at all our boundaries, whatever we had, so they are all done. So now we can directly go to our EC2 instance. If you have followed so far, VPC we created, two subnets we created, and two routes we created, and we made entries for this. If you look at, we didn't add this entry yet. So first I want to show it. We also not even created NatGateway yet. So first I want to show that internet is not working. Then I'll create NatGateway and make this entry so that you will see that internet is accessible there. So yeah, with that, let's first go and create our EC2 instances under this. So I'm creating an EC2 instance in the public subnet and another EC2 in private. So let me go here to EC2. This time, I think for easy reference, maybe I'll use. Last time I created Linux. Maybe this time I'll create a Windows. I'm taking CD. So Windows Server 2019 is FreeTier eligible. I'm taking this. Next configuration. Yeah, so this is where our custom routes should be there. So it's always only one VPC is there. So this I want to make it as a public. I want to create a public EC2 first. So I'm selecting public. This is being a public. I want to get a public IP. So I am enabling this public IP. For private, I will not enable this. So when it's a public, I'm enabling a public IP. So add, yeah, and here I think it can be default. Here this can be default. Here I just RDP is there by default, remote desktop. So I'm additionally adding HTTP. Basically, I'm enabling port 80. So this is where the security group where he will tell what should be enabled and what should be disabled. Just making it anywhere, but this is generally not a good practice. But I'm just making it open to all so for now. But generally, it's not a good practice to use this HTTPS. I'm enabling both port 80 and port 443. So both are accessible. So that this will where you get internet. So all google.com or everything will talk on HTTP, and HTTPS will be on 443. Okay, so review and launch. And just kind of review and then launch. I'm using the same demo key pair which I used before launch instance. So while this is running, I'll create one more EC2 instance. Now this is for private. Windows. Here now I want to give private subnet, and I don't want to assign a public IP to this. That is private. Next, next, next. Here, yeah, HTTP. And also for something, all ICMP is for prime for ping. So I'm trying to add that as well. All ICMP. Then so that I can do a ping on this, and also other this ping also should require a privilege. So should allow it unless. So I'm just reviewing CIDR. Okay. Launch. Okay. So we should be having two instances now. EC2 instances. I can ignore the terminated ones, which will eventually will go away. This from my sample, but yeah, these two are the new ones. So this one is yeah, I think this will have public IP. So this is the public one. I'm just putting as new public so that this, okay, and this one is this is okay, yeah, this one can be okay. So this is a public EC2 and this is a private EC2. So now let's connect to public EC2. And yeah, this time, yeah, you download the RDP, get the password. You already have the PEM file which I downloaded first time, so I'm selecting that. So it will decrypt the password. Now this is the new password to connect to your Windows machine. Pasting the password here. Now this connects me to the public of the Windows. So similarly, let me download the same thing for private as well. Yeah. So, yeah, I think this private may not be needed because anyway you'll not be able to access it because it's not having public IP. So yeah, so I think private is no point in connecting it. So basically we need to connect to the public. Sorry, we need to connect to the public IP. Yeah, so this is a public IP. I have not connected to private. This is a public IP machine. Uh, we will not be able to connect to it also because it is not having public IP. So we will not be able to connect also. So there's no point in downloading it. So yeah. So now this machine is all up and running. This is a Windows virtual machine that we created. So this is if you see here, this is the public IP which is matching to this IP, and the private IP is this for this. So if I now try to ping, for example, this IP address of this, yeah. Uh, so yeah. So if you look at here, yeah, I just want to look for this ping command. So what it does is so basically you can uh, connect to this what we did is we connected to this public IP and from it, basically you can't connect this private IP directly from here from your machine. But what I want to show, okay, off track, what I want to show here is um, how can you connect to, you can't connect this private VM, okay, because it's created in private subnet, so you can't connect. So how can you connect to that machine? I mean, this is something which is different, which I want to show it to you, because I want to show you, I want to introduce a concept called Bastion. Bastion or jump host. So that is what the terminology that we use. That again, that is a very common terminology where to connect a private VM, you connect a public VM, and from there you connect a private VM, because they both are in the same data centers. So you can connect to this private VM from this public VM, but you can't directly from a laptop. You can't connect to a private VM, right? So yeah, so that is what I want to show it to you. So what I want to do is I want to connect to this private VM from this public VM. So this is a public VM. So inside that I'm planning to open one more RDP and want to connect. I think it's already there. So inside public, I want to connect to private. Okay, so let me go to the private IP here. So the password is administrator. So here I need to get the password. Connect. This person. So this is the. I should follow the same process to get the password. Um, now user ID is administrator. Password is what I'm going to copy now. See, now it could connect. So basically, from my public IP, I could connect to a private IP. So this is possible. So this is very common technique that will be used generally if you don't have NAT gateway. I mean, generally if you don't have a NAT gateway, and let's say if you want to debug something on the private EC2 machine, so generally you connect to public, and from there you connect to the private. Uh, so this is a very common again interview question as well. So they will ask what is if you want to connect to private subway, what are the options you have? So one option, the only option to connect to private subway, if you know the public, is through the jump host approach. So you're connecting to public, and from there you're connecting to private. So that's why it's called jump host concept or Bastion. So these are two technologies that they use in AWS. And I think it's a very common technology for all the clouds. Um, okay, so yeah, so basically what we are now connected is to the parent. So what I will do is I will disconnect the from the parent from the private subnet. So now I'm back to my parent. So my parent Windows server is public one. So yeah, so now what we'll do is now let's open. Uh, oh, why I disconnected? So I think it got connected. So sorry. So I want to show the internet is not available there. So that is the reason I connected. I forgot to show that. So let me connect back. Okay. So now I'm back to the. So if you look from here also, you can find out. If you look at this not having public IP. So this is having only private IP. Whereas the other one was having both public and private. So this is one way to even check whether they're in which VM. Okay, so this is having private IP only, no public IP. So now here, if I come, I just want to show you that there is no internet. So what I can do here is can come to one easier way to check is from you can use various ways, but yeah, you can put even browser and check whether internet is there. But the other option is to check 8.8.8.8. This is Google's internet site, and just trying to ping it, so which ideally should not connect because there is no internet. Should have give a request timeout. Also, you can go to here and you can check. Should not have internet here. Yeah, it will wait, but yeah, finally you will not see any records. The results coming. So which basically it's so it didn't show anything, right? So it doesn't have internet permission. So summary is so basically now what we'll do is we will now do that create an NatGateway now. So let me close here. So what I will do is I will go to VPC and now I will create a NatGateway. Basically, what we are now trying to do is to add this component. This will be in public subnet. So ensure that when you create an NatGateway, you select a public subnet, and then it is in public subnet, and you will link that in the private subnet's root entry. So this entry. If you make this entry, then this guy will get internet access. So that is what we are trying to do now. So let's go to gateway. Let's go to NatGateway. So there is something in NatGateway is already there, but there is a deleted state, so I want to create a new one. So this can be any name for that matter. I just giving. Yeah. So if you look at here, so this is where I will select this, where I need to create this NatGateway. So this I should create it in the public subnet. So I should select the public subnet here. So and then I want to allocate an elastic IP for this. I don't have any elastic IP, so I'm just going to create an elastic IP. So this elastic IP is created and create an NatGateway. So now I can go to edit root. Yeah, and here if you see here here I will basically create the there will be an entry for private root. So here I will go and make an entry here. So here I need to make an entry like this. Here I will select NatGateway. So this is what I'm making the green entry, what we saw in the PPT. So I created this now. So basically what I did is I went to the private root and then I added this NatGateway entry. So that is what you see in this box. This now I added. Now as and when let me check whether this gateway is created. NatGateway will take some time to create this in pending status. But yeah, as and when you see this created, we should be able to get the internet for that. Yeah, but yeah, in the meanwhile, do you have any other questions? Yes.
So if you guys see, what we did was simple hello world example in networking. That's it. We didn't do much, but just to do this, how long it takes and so many things we have to take care, right? So there will be lots of human errors comes. And once you create also, how do you make sure is it what you are intended? So you need to test it, right? So penetration testing, there are lots of, with this cloud way, since it's infrastructure as code, people has come out ways to load test it, penetrate test it, security test it, DDoS test, everything is all codified. So that is the power of automation. So that when you have to develop 500 such resources, once you have to struggle, first time it might take a little bit more time, yes. And once you made it work, and once you make the testing also work, then you could put it in the dev stage, prod, and beyond. And for example, okay, I don't like the way this particular compute is working. It is slow. So the same script, you just change the parameter from T1 micro to something else, right? So your code, you don't have to go through the steps again manually. I actually realized all this once I started working the power of automation. That is where these guys are counting now, the real productivity wise.
Yeah. So
So Sham, one question here, right? Like,
yeah.
so this is all good. Maybe it's a little question getting ahead of our course, but so usually a software or something has a version, right? Like, so something saying, okay, version 1.0, then version 1.2.0 comes in, it obsoletes or deprecates some of the things that you have in 1.0.
Hmm.
So in AWS, EC2 is almost, I think it's still there, but I think something else new has come. So are they still backwards compatible or what is it actually, right?
EC2 is not going away, man. EC2 is the premise for Kubernetes, is premise for SageMaker. So internally, everything is betting on EC2. EC2 is the foundation.
Yeah. That is
Extra compute all coming around it, not replacing it.
Yeah, that's true. I think internally, whatever products that are coming now, so yeah, I think they all use the concepts of EC2. But behind the scenes, they are using the concepts of creating a compute and resources and other things. But yeah, I think that is what we are seeing is definitely basics which we should know starting point. But I think as and when you go, I think every day AWS is evolving. So, for example, all the new products that are coming up, it's some of them are kind of a better version of previous product, but with a different branding. So they're definitely not throwing away the old product, but they're giving with a different brand name, but more or less uh, like like 40%. If you see most of the products, there'll be at least 20 to 30% commonality between the products. So that is because every day they're launching a new feature with a better version than what is previous, but with more features added to that. So that is a marketing strategy. But yeah, so
Okay.
every day that new product that we're getting is more or less you can see. I mean, once you understand these products, right? There'll be at least there'll be it is difficult to identify what is the boundary of a product. Some products can go between two areas. For example, a product in security, if you say, I still get confused in security area. There are at least four products are there. What is the boundary for a product is difficult unless you know the very details intrinsics of the product. But yeah, as it is evolving, I think to answer your question, yeah, every day there is a product coming in the market from AWS which is addressing the pain points of the previous product with a new brand name.
Okay.
But still,
So,
for they're
so,
maintaining the legacy, they're still supporting the older product.
mhm. So
Tom,
this
I
is
think
a very high level thing. Like, so would you call AWS an infrastructure as a service or platform as a service or software as a service? Which one is it?
It is having
Which
all
category?
three, all three.
All three.
Yeah. Yeah, I mean, it depends on the product that you choose. For example, EC2, if you take, it is depends on from which angle you see it. I mean, if you see infrastructure, this primarily from an end user angle. If you see that is as an enterprise, I'm using this AWS product. I see EC2 as a infrastructure as a service because I just get a VM only, but it is up to me what I'm going to install in that VM and make that as I can make that as a database server, or I could make it as a web server. It is up to me. Uh, so so what I'm getting is just infrastructure, like a virtual machine. Okay, so that if you see that angle, that is infrastructure as a service. But there are other products, for example, Lightsail, which is a managed version of the compute. So you don't need to bother of many things. So AWS will manage everything. So if you see from that angle, that is more PaaS service. So you can just double click it, you get an EC2 instance up and running. So you can start using it. So and all the operating systems, patches, and all those things will be managed by AWS. You don't need to bother. Even for example, the RDS that we saw just now, I think I was showing you the RDS database. That is also a similar category. It is a PaaS service where you're not required to do anything. You just use the software. That's all. All the patch upgrade of the databases, everything will be managed by AWS. So that comes under the PaaS category. Yeah. So it depends on what software you're using. So yeah, it has everything. Right. Yeah.
I think Shyam,
Yeah.
Raj here. I think maybe the question is slightly different. Maybe this is what the original question probably was intended for, is who manages the patch of an OS or the database in case you need to update it. Let's say when you use the standard EC2 instance, which comes with the image that you use it, and then you develop a software which requires a latest patch. Are you allowed to update the patch in your instance, or it's not possible, or will it be done by AWS? I'm not
Okay.
sure if you understand.
Yeah,
If I'm clear.
understood your question. So yeah, so it's a very good question. So the answer is it depends on what type of product that you're choosing. Let's talk about first EC2, where you are responsible to maintain the patch for its operating system. So let's say you're taking EC2 machine and you are deploying some database software in that EC2 machine. So now your database upgrade is coming, and that requires a higher version of patch to the Windows operating system on the EC2 level. So, so, so you so you are responsible to download the latest patch on that EC2 machine, and then ensure that your database is working. So it is in your hands. You need to do it because that's the infrastructure as a service. But whereas if you go to managed services from AWS, various products are there under managed services. The same concept. There, AWS is responsible where you can suggest AWS. Mostly they will do the patches as a global rollout. As and when there is a new patch, because the managed service, they will do a rollout to all the users globally if there is any patch coming up. But just in case if you want to be ahead in the curve and you want the latest and greatest which is not rolled out yet, so you can make a special request to AWS, and they will, based on their preference, it's up to them now. Based on their preference and priorities, they will either accept or reject. But generally, they are responsible to do that upgrade. So there you don't have a control. I mean, you can request, but yeah, it is up to them to decide. But generally, their top priority. If it's a managed service, they always ensure the patch upgrade is in their hands, so they will do it. You don't need to bother about that. But generally, they do the upgrades as and when very quickly. But yeah, in case if you have a special requirement where this patch is released just yesterday and you want it today, so then those are special cases. But yeah, you can negotiate with AWS.
Thanks, Shyam. Thank you.
Okay, so yeah, I think we just created that that was available, and after that, if you see the timed out case suddenly converted to sorry, this you're started getting a reply, so which means that it has internet now. So I just quickly showed while you're talking. So I click Google and it's internet is there on this. So now your private instance is private IP instance is now having internet. So that is because you associated a NAT gateway in the route. So that is the idea or demo which I want to show. Any questions?
So we kind of covered the scope, right, Shyam, right now, from what you want to cover?
Yeah, yes, I have, but I think I have a planned one more demo, but it depends on the time. So I want to cover the VPC peering also, but maybe otherwise I will do the theory part today. Maybe the following week I will do the demo part.
And probably one suggestion might be all these demos are very good, but we want to cover a little bit in depth of theory also, like
Yeah.
so that sparingly we'll cover the practical side, because if your objective is to pass the exam to start with, right?
Yeah, I have the theory session
Hopefully, the more
also.
the theory knowledge will help them to study the course.
Yeah, correct. I have the slides for the theory part. But I mean, as I said before, my intention is to give the demo so and then come to the theory part so you will understand it. I have theory slides for it. I will cover.
Sure.
Yeah, I think I said like I want to try something different from the last demo also. Basically, I want to give the demo first and then come to
Yeah,
theory.
yeah.
Then people will understand what I told. So yeah,
So one interview question here. For example, you guys see a public subnet, private subnet, two machines. You cannot connect to the private subnet machine directly, right? Usually, private subnet is a database machine, and the public subnet is like a web server kind of a thing. So only from the web server or app server, they will have access to the database. So even in on-premise things, they kind of follow that same thing. The question is, okay, you just to connect to the private machine, you have to go through all these steps. And for example, if you are a database administrator, I don't think it's reasonable for them to go through these hoops. So if there is a better way. So the answer is I couldn't find the answer immediately, but later I found that VPN. So once you have VPN, right? So from your company VPN, you connect to the company network. That means you can able to currently see all your private machines of the company. Correct? Same concept. Here also there is a VPN you could establish. Once the VPN is established, you could directly connect to the private IP. So that is the answer.
yes, yeah, yeah. So I'm just disconnecting this.
So that VPN gateway was also like a part of the configuration. Means
Yeah,
you have
it's all
to.
part of the customer. Yeah, there is a customer gateway, there is a virtual private gateway. So
Yeah, so
there are products. One, you have to do a little bit on the customer side. Yeah, you have to do the configuration. Once that configuration is established, then you could able to connect through as a VPN. And once you connect to the VPN, you can connect to the private IPs.
yep. Okay, so let's move further. Maybe what I will do is since you have less time, so maybe I will quickly run through the theory part. So maybe for the demo for the VPC peering, we will cover it in the next session. So yeah, so before that, let me give the context of VPC peering. So VPC pairing is kind of a bit advanced. I think it's the same question that we got in the last session. So this generally the VPC scope is restricted to availability zones, but there will be requirements where a VPC created in let's say in Northern Virginia in US want to connect to a VPC in Mumbai region. So you have a requirement like that. So then ideally it is not possible to connect. So that's where there's a product called VPC peering, which we need to establish. So that will do the inter-region VPC communication. So that is again, and question will be some in exam will be something like this: two VPCs and different regions they want to talk. What options? So what options you have? So option is VPC peering is the answer. So primarily this will allow the traffic between two VPCs. Primarily there are two categories. One is the regions that we spoke, which is called inter-region VPC peering. Uh, but what about a scenario where this VPC in a different AWS account? So that is also a possible scenario. I mean, this VPC is in my AWS account, and let's say this VPC B is in Srini's AWS account, and you want to make these two talk to each other. So such case also a VPC peering is required. So Shyam's VPC with Srini's VPC in between these two, we should have a VPC peering. Only then they can talk to each other. So these are two cases where VPC peering will help you. So generally in the demo I will show you this, but typically if I want for this VPC A to talk to VPC B, then generally the owner of the requester VPC should send a request to the owner of the acceptor VPC. So this is a requester VPC, let's say A to B. So this guy will be requester and this guy will be acceptor. So yeah, so from A I need to send a request so that B owner of this B should accept it. So then they both can talk to each other. So only then the line will be activated. So and so this peering concepts, right? So this is it also, if you see this, I mean that is what I showed here. I mean, in the UI you will see this screen where and when you create a VPC, there will be something called VPC requester, and then there will be on the other side of VPC you have options. Either you can do it at account level, which is this AWS account level, or region level. So this is what these options are. The demo today, what I planned is actually at a region level. This is this came as the question last time, so I thought I would share that. So in the demo, what I planned is to create this VPC in Northern Virginia, I think, which we already have now. I want to create a similar one in Mumbai or any other location, and then create a VPC pairing between these two guys so that these two can talk to each other. Like you can max ping from this to this and this to this, so you should be able to do it. So yeah, that's what I want to give a demo today. But yeah, I think we'll do it tomorrow in the next session. Other important thing is this. If you see at the star configuration, this is something an interview question that can answer, an exam question that can come. So generally, this uses peering uses a concept called star configuration. For example, what do you mean with star is like if there are multiple VPCs which they want to talk. Okay, let's say A is connected to B. Okay, and C is also A is also connected to C. So, but it doesn't mean that B and C can talk to each other. I mean, AB, AC, then BC is by default connected. No, it is not. So between two VPCs, dedicated line should be there. So basically that's why it's called no transitive pairing. So this is one question that can come. Whether transitive pairing is possible in VPC connection. The answer is no, because when I say transitive pairing, AB, AC, then BC. So that is transitive pairing, but that is not supported. So in VPC pairing. So that is something we should keep in mind for interview question. And similarly, you should ensure that there is no overlapping of CIDR blocks. When I say CIDR blocks, this IP range is CIDR. So this IP range, we should be very carefully. We should select such a way that, for example, this IPC, for example, this is 10.0. This should not be 10.0. This should be there will be clash. So this should be for example, different 172 dot, for example. So there should not be any overlapping of IPs. So that is very important for VPC pairing. So
during hybrid cloud configuration, you have to make sure it should not even collide with your on-premise IPs also. So at any point, the IP should be distinct.
yes,
Yeah, that is one of the key things.
exactly. Okay, any questions here in VPC pairing? Okay, so let's move on. I think I think I covered. I will give a demo of this maybe in the following session, considering the time. But let's quickly cover on some the aspects that we already covered. I think that Ashwini said, like the theory part from exam point of view.
Shyam,
Yes.
just one question.
Yeah.
Does the VPC endpoint has any connection to VPC peering?
VPC endpoint. Oh, the VPC endpoint that you are talking here.
Right. So, what is there any relation or any application? I mean, is there any relation between VPC endpoint and the VPC peering? Are they
Yeah, the scope.
related?
They're related to some extent, but the scope matters here. I mean, the VPC endpoint is it doesn't talk to I mean, across regions. This is not supported. For example, VPC endpoint is not supported across regions. But the use case for VPC endpoint is basically two VPCs within the region, or the one VPC.
No, VPC
Resource.
endpoint is for securely accessing the VPC, right? So that you don't go to the internet way. But this peering is across VPC communication. So the confusion is the naming, but it doesn't have any correlation.
Yeah.
Okay.
So the VPC endpoint is something where one resource within a VPC can talk to another resource within the same region. For example, let's imagine a scenario where we have VPC and then there is a EC2 instance inside the VPC, and there is another product. Let's take storage in S3, for example. S3 is another product. So you want to, but that is not in this VPC, even though they are in the same region and same availability zone. But they are not related to each other because VPC is a boundary between these two. So in that case, the VPC endpoint will make a far better solution where it provides a solution without internet and they both can talk to each other. But it is not suitable for a internet-based requirement. This is not suitable, and especially we are talking about across region communication where it requires internet. So that is not. There is another product for it, which I will cover. So VPC endpoint is not for the global connectivity. It is within the scope, but without internet. So that is a use case for it.
So, so the VPC peering then does it go within the AWS infrastructure without touching the internet, or it does go through the internet only?
It goes through internet. It goes
Okay.
through internet. Yeah.
Okay. Thanks.
Yeah. Okay. So yeah. So let's come to some basics from exam point of view. Um, so I'm not sure if you're comfortable. Yesterday after the session, the last session, I got some questions asking about what is IPv4 addressing and how this works, and so such kind of questions I received. So I thought I will add this slide to make it more clear. So this is something basic concepts about how this IPv4 addressing works. Um, so basically, this is called CIDR. When you say in the exam, wherever they are referring CIDR, which means they are talking about IPs. So basically, CIDR stands for classes interdomain routing. So it primarily is a set of IPs standards, and that is it's kind of a global standard for how this IP should work and how this IP should be created and what should be the logic to create, but what even with slash 16, for example. So all this all defined by this CADR. So it's standard for IP protocols. And yeah, so basically, this is from exam point of view, very important thing is we should know that there should not be any overlap with other networks. So it is very important to ensure that all the IPs that you're allocating for various subnets, public subnet, private subnets, VPCs, across VPCs, everything you should make a note so that your IPs are, when you create a new VPC, you ensure that this IP that you're providing there shouldn't overlap with the existing one. So this is very important. And there are, I mean, there are some notations for it. For example, as I think Srini already mentioned in the last session, for example, slash 16, what does that mean? Slash 16 means like generally like 32 minus 16. The concept is 32 minus this number. So whatever you get, that is a 2 power of that. I mean, so 2 power 16, for example. So 32 minus 16 is 16. So it's 2 power 16, which is 65,536 addresses. So this means that you will get 65,536 addresses in this if you define it like this for the VPC. For example, here the slash 16 can also take other values like slash 24, slash 28. Again, the same concept, 32 minus 24, 2 power. So the two, so which is 251 addresses or 16 addresses. So that is what this stands for. And
So one more interview question is, there are some reserved IPs. For
yeah,
example, when you say slash 28, you get 16 address, but you don't get 16 address, 16 minus 5. So there are five addresses which are being used.
correct. I covered it in the next slide. So that is coming. Um, so this is what so you understand this notation, right? So basically, this defines a range. What is your range of addresses that can that this range can go to? For example, there are very good tool. There are a lot of tools are there, but I think I found this very interesting. CIDR.xyz. So if this is a tool where you can look at what is the range. So you can directly click here. So it will take you to this page. Um, So you can, for example, here you can tell, for example, the /16. So here it will tell you that if you're giving /16, so 65,536 counts are there. So this your first IP can start with 01, and since you're mentioning 0.0, so 01 till 254, 255 or 254. So that is the this range is like almost 65,536 IPs you can get in this range. So with just this mentioning this, so you get this range so of IPs. So yeah, but
So, Shyam, so this is the same concept as subnetting, right? Like basically you're
yeah,
grouping your,
correct.
so that's the
The
same
concept
concept,
is
right?
same. Yeah, concept is same.
Yeah.
The
So
IPs and
16 means 16 bits. Yeah, last 16 bits is kind of exposed for available for addressing.
correct.
And the
So for example,
right, okay.
/24, if you give, you get 256 counts of addresses.
Yeah.
So /28 will give 16. So like this, yeah.
Shyam,
Yeah.
just a quick question. So just a quick question. Why should I give 24 and 28 when I use 16? I have a very good number that is available. So it is just an allocation. Either I use it or not is at my discretion. So why should I go for 24 and 28 here? I could as well go for 16, right?
Yeah,
What is the
generally,
advantage in using 24 and 28? Possibly I will redesign the question.
yeah, very good question. So generally, if you look at here in one VPC, so we generally give a very big number for a VPC because for /16 is generally commonly used for a VPC. But inside that VPC, you have a lot of subnets, public subnet, private subnet. I can add n number of public and private subnets. So that's why for the subnet, which is like I'm forming a sub boundary inside the broader boundary. So I'm forming a boundary, network boundary within that. So here I will use /24. So which means I will get, if I use /24 in this, for example, I get 256 counts. So I'm splitting
256.
that 65,000 into 256 for public subnet. Similarly, 256 for private subnet. Likewise, I can split that 65,566 into various, splitting it into sub. So that is what
Okay.
the concept is.
Okay.
So
Okay.
yeah, so that's why when you create a subnet, your IP range here it should, for example, I will zoom it and show it. Yeah, when you giving this 10.0.0.0, your subnet IP should be within that range. For example, it can't be 172 dot, for example. So it should be within this 10.0. It should be 10.0, 10.0. So this is 0 for and this is 1. So likewise I'm splitting it. So subnet should be within this VPC boundary. So I can't give something random here.
Okay.
Which
Okay.
I'm
Okay.
splitting it. Nothing but I'm splitting this border into small chunks.
I think Bala, is it maybe you asked the question. So what I understood is when you create a network for the corporate, you give the /16, so you get more number of machines, addressable machines, and
Right.
then you bisect them or you them into smaller network, maybe one for testing, one for QA, and one for deployment. So each one of them can be 10.0.1, 10.0.2, and things like that. So you create the subnets. So each one of them is a silo by itself. And
Okay.
when you give the /16 or /24, the leftmost 16 bits or the leftmost 24 bits are common. So when you say /16 in the 32-bit addressing, the left 16 is same.
Okay.
So this bigger the number, the smaller the machines in your subnet. Smaller the number, the bigger number of machines. So that's what senior thing. Someone said 32 minus 16.
32
So when
minus.
you
So you could
have
have sold.
38,
Yeah.
and
So the
and
question is, Raj, the
Okay.
question was, I think, why to choose 16 versus 32? The answer is, you think about your growth, right? So it's better to have something bigger so that you could expand more. That's the only thing. There is nothing else beyond that.
okay.
Okay.
Yeah, I think this is a very important role for a networking guy. So to decide, I mean, he will ask a lot of questions when you ask for a network. I mean, he will understand the requirement, like what is your plan of growth and what is your future, how many more machines you're going to create inside, how many IPs you need. Based on that, he will decide this number. Yeah, but now as a AWS architect, so we should also know this networking concepts here. But yeah, the concept is that, so it depends on your usage.
And one more thing is, since it's all very cheap, right? Previously, a machine is costing so much space, people, but nothing now. It's a click away, right? So people actually, even though if you are a mom and shop thing, you might have so many of them. You keep even Sham, you would have created so many machines, stopped the machine, stopped it. So yeah, so it's better to have a room in the network.
So,
Okay.
the question clear? Answer clear?
Yeah.
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 Okay.
Yeah. So what I understand is the 16 will give a lot more room, and within that, probably the 24 and 28 will give a family of grouping within that.
Exactly.
Okay. Thanks.
Okay. So, but the numbering is how you plan it inside how many rooms you create. You should make a note like which room you are allocating for whom. So otherwise it is difficult. At some point, it will be difficult to track these numbers. So yeah, so that is very important. So that, as I said, like when I say overlapping, that's what we mean. So there's no other tool to manually check. You have to go physically, make a note of this, and then yeah, keep it handy. So so someone asks for a new room, then you should see which rooms are available and which IPs are not used, and then accordingly you should allocate. Yeah. So typical networking guys headache. So yeah, but yeah, that comes as our headache also now. Yeah. So yeah, and then this yeah, and then there's another important thing which you need to know. So there's a range of IP addresses that is very commonly used. Especially these are called generally they come under the category of public IPs. So generally for all the public IPs, you get IPs either starting from 10 dot or 132 dot or 192 dot. So these are the most common public IP ranges in any cloud for that matter or anywhere. So these are public exposed sites will have these numbers. But again, this is something the RFC, which is standard for as defined that these should be the range for this. But that's why the public IPs that are generated by AWS will not have this. I mean, they will have 52 range, but so that is AWS specific. So that's how you differentiate an AWS specific versus a public. So the private range, if I'm talking about the private IPs, generally for AWS will start with 52, but for the public IPs, generally for from AWS they start within this range. So yeah, mostly I mean this is just a convention, but it's no hard and fast rule that you should give these numbers. But generally a convention globally followed. So yeah, so just another sideline information for IP addressing point of view. Um, yeah, I think Srini said so. There'll be reservation of IPs. So from AWS point of view, so generally AWS reserves few IP addresses, primarily the first four and the last. So typically the five IP addresses, AWS will reserve, even though you give a range, so you will not get the complete range. So for example, 16 if you give, I mean for slash 20 if you give, you get 4096 IPs. But out of this, for example, these 0, 1, 2, 3, I mean the starting number followed by the next four, 0, 1, 2, 3, and the last one, 15.254. These IPs are reserved by AWS, so you can't assign these IPs to anything else. So just keep this in mind when again another common interview question. It's coming in interview, so a common AWS exam question. Okay, so and this one and another one is this internal IP addresses. So yeah, so as I think we already covered this point. So generally this IPv4 the VPC range that you're getting here. So this is a broader range. and under that your subnet range should be within that within that broader VPC range. So this is smallest family room inside a bigger room. So yeah, so that's, I think we already discussed this. Again, inside that there will be an EC2 instance in the under the subnet. So again, it should be also taking some value within allocated to this range. For example, /20 if we give, this can range from .04 to 15.54. So all our EC2 instances public IP should be within this range because it is under this subnet and broaderly under this VPC. So yeah, this is how you split this generally. Yeah, so basically the subset CIDRs, basically subset of VPC CIDR, it should be subset of VPC, and also subsets cannot overlap. That is very important, and ensure that you have enough capacity. I think this is what the planning is very important when you create a VPC. So what is your growth and other things you should consider, accordingly create a capacity for it for a future growth. At some point you will not be in a situation where if you give a smaller range and then finally you decide you can't add one more machine to that, then yeah, you're in a problem. So that's why it is important to do this planning of how much you need, the capacity planning. Based on that, you decide what should be the range for your VPC. So yeah, I think we discussed this. Okay, so far we all spoke about IPv4. But how about this IPv6? So IPv6 also follows a similar concept, but the concepts are same, but just that the number is a very big number. For example, /56 in IPv6 can give you so many addresses, so many combinations. Like for example, so this is not 65,536. This is even some 100 times that number. So uh, and /64, for example, will give so many addresses like this. So generally, IPv6 is since we are running short of IPv4 as a common problem, IPv6 was introduced to address it. So and now AWS supports IPv6 as well. So yeah, so that's why when you create a VPC, you
So,
get both options, IPv4 and IPv6.
so Sham, is this a 64-bit or 48-bit? I thought V6 is just 6 bytes, but looks like 64.
64 only. Yeah,
Oh, is it 64?
IPv6
Okay.
can take these ranges.
No. The IP length. I mean,
Oh, okay.
generally in V4 it is only 4 bytes, which is 32 bits, right?
Yeah,
So IPv6, I thought I didn't even read about it, but it's only an extra 2 bytes. But it seems like it's double IP4 V4,
yeah,
right?
yeah, correct. Yeah, so
Yeah.
it can take such a bigger count of addresses. So
Okay.
yeah, okay. So yeah, just keep this in mind. Now IPv6 is also supported. Just yeah, but there's many people still following IPv4. But once we come to a stage where IPv4 is running out, then we should start considering that and move into IPv6. Okay, so I think exam point of view, I think we covered internet gateway. So internet gateway is something that allows internet to a VPC. So I think we saw that. But one important question is that it is not just internet. I mean, it supports two things primarily. Generally, it provides a target in VPC route to enable internet traffic. That this point we know because we added IGW in the route target and then it started giving us the internet access. But just now we saw the second option, the NAT. It will also perform the NAT. We introduced a NAT gateway and we allocated that NAT gateway in the public VPC, right? So what we saw in the demo now. So that also comes through internet gateway. I mean, how are you getting internet to a private? So we're telling we are getting it through NAT, but NAT internally uses internet gateway only, as Srini said. So that is the second point. So this is the second point is a common interview question. Again, it's coming interview. So again, the exam question. Um, so to perform, I mean, generally the requirement, the questions will be something around you need a internet gateway. So I mean, you need a internet to a private instance, and NAT gateway is providing you a solution. So what NAT internally uses to provide the internet? The answer is internet gateway. So NAT internally uses internet gateway to get the internet for the private instances. Yeah, and yeah, the last one, yeah, it is. I think we already covered this. I think we destination generally should be 0.0.0, so that like it is a public IP, right? So anyone can access it. So when you're providing internet, anyone can access it. So this destination value should be always 0. So like if you give star access to everyone. So and IGW should be selected. So yeah, generally this is how. Yeah, so this is a route table. So and internally it uses router, and from there internet gateway. So this is the internet gateway symbol, for example. So something like this. I mean, every component of AWS has a symbol. So this is a NAT gateway symbol. Uh, any questions here? Okay, moving on. Yeah, very important from exam point of view. Security groups and NACLs. So if you remember, these two come under the security aspect. I think we showed in the last demo. We generally give a security group. If you remember, we gave the what port to be allowed, like RDP port, and similarly HTTP, HTTPS. We allowed all those things, right? So those are security groups that we created. So this is a diagram where you can understand. They both come under security group, and NACL both come under providing security to your additional security to your instances. So, but the scope is very important. So the very important from exam point of view also. The scope of security group is, as I mentioned here, this determines the traffic at instance level. That's why it is there inside your subnet. Okay, so it is at instance level. You define what this instance should have. Like it should enable. If I create a security group for HTTP, then only HTTP only will be allowed. If I give HTTPS, only HTTPS will be allowed. If I give RDP, RDP, SSH only. So that is the rest of the ports are disabled. So that is what is given by security group. So the scope of security group is inside at instance level, at lower level. But whereas NACL, which are network access layer, so this is something which is at the upper level. I mean, which at a network level or a subnet level. So that is very important to know. That's what I mentioned here. So security groups determine traffic at instance level. Primarily, the to or from instances. Primarily, you generally tell what port and what protocol and what should be a source and what should be a destination. So those things all you define in security group. In NACL, yeah, generally they determine the traffic at a higher level, which is at network or subnet level, and they will also have some rules to either allow or deny the traffic in and out of the subnet. So you can tell what IPs should go and can talk to this instance. So we can define allow and or deny rules here. I will cover this NACL in another section. So you can tell that rules here, allow or deny rules. So sometimes when you get a request accessing for instance rules, unless it passes the NACL rules and security groups rules, only if it passes, then only you can access it. Otherwise, you don't have the required privileges or your request will be denied.
So Sham,
yeah.
Is firewall rules and NACL are one and the same?
Yeah, firewall rules and NACL rules are, yes, they are one and the same.
Yeah, firewall rules is split across 3 here, right? So if you see route table, NACL, security group, all 3 together translate into a firewall rule. And other interview question is, if there is a hacker IP, if you know that somebody is keep on hitting your service, you want to block it, where you can do only on the NACL side, because that is the only place where you have deny. Security group you cannot deny. So that is also.
Yeah, I have a very good table comparing the difference, because it's very tricky questions from exam point of view. It's very important to know the differences between these two. Because both play the security role, but what is the difference? So they give a scenario in exams and generally they trick you. So yeah. So just before going to the next slide, I think so generally so as well like this security group at instance level, NACL at a subnet level. So let's say if you have many instances managing the firewalls, then generally you will use NACL. So NACL is where you define especially when you're managing many instances, you define the firewalls at a NACL level. Otherwise, if you're talking about a couple of instances, then it's sufficient if you just define the rules in security group. That's sufficient. So but yeah, typically in enterprise you have both. But if you're doing a POC purposes, then security group settings are sufficient. But let's say if you have a fleet of instances you're managing, then it's always good to have a second level of defense, which is this NACL. So yeah, so that is the context. So basically you should start with security. Security group is the first level of defense from security angle. But this provides an additional security on top of this, a kind of second level defense. Okay, so yeah, just I think to summarize this, I think yeah, this security group versus NACL applied at instance level. This is at a subnet level, one level above. Very important point is security group is stateful, okay, whereas NACL is stateless. What does that mean? So when I say security group, like if the incoming port 80 is opened, then automatically the outgoing port 80 also will be opened. So inbound and outbound, there are two categories under both. So like how much inbound is like incoming traffic, outbound is outgoing traffic. So basically in security group, when you say incoming 80 is allowed, port 80 is allowed, then since it's being a stateful service, it automatically saves that even port 80 is also allowed. So it is stateful and it is both are applied. I mean, incoming 80 and outgoing 80 by default is open. But whereas in stateless, you need to explicitly tell what to allow and what to deny. So that is one important difference between say security group and NACL. So that's why it's for stateless. So if you want both, then you should explicitly define both to allow inbound and outbound. So and then other one is security group generally only allow operations allowed. I mean you can do only allow. I mean there's no deny option. Okay. As Srini said, if there are any questions saying that I want to deny a traffic from this particular IP, then you can't do it at security group. You should do it only at a NACL level because the deny is only available in NACL. So here there is no deny. So all allows only. I mean, when you say deny, it is not there. What does it mean? Is like by default, all rules are denied here. You can't if you want a custom requirement where this particular IP alone, if you want to deny, then you can't do that here. So you have to do it at NACL level. So there is no deny here in security group. Okay, and yeah, here in security group, all rules are evaluated, and like there's no order for rules. But here NACL has rules like in terms of every entry will have a priority. So you can tell 1, 2, 3. Likewise, you can give a custom numbering, which means that like lower number will get the highest priority. So that rule, if you can tell, you can give a priority to the rules here. So that is what this NACL advantage is. And yeah, security group is applied at instance level, instance only. I think we know that. But here NACL, the rules that are applied is applied to all the instances which are associated within that instance. So it will apply to all the instances because it's at higher level. So it is at higher level, it applies to all the instances. I mean, all the instances within that group. Sorry, all the instances within that group. But whereas the security group is specific to generally typically give it to a specific instance. The scope matters there. So, yeah, I think we already discussed the last one is like first layer of defense and second layer of defense. Yeah, I think let's break here. So I think this is a different topic. So let's yeah, I think any questions here before we wind up?
So Sham, So this one, right? Like these are. Is there a common, what do you call, concept level thing that we can learn before coming to back to this? Actually, right? Like on our own. Actually, if you want to know about ACLs or security groups, I don't know. It's a general concept that is available out where they have Amazon has implemented. Do you suggest
Yeah,
that, or this is something?
yeah, that Udemy has the network section, right? They covered very good these things. That
Okay.
guy talks a little faster, but if you can able to cope up with the speed, I think it's a very good course. Just listen to the networking side of it. He's covering all this in depth.
Okay.
Yeah. Yeah, I think it is a mix of both the common concepts and there are something very specific to AWS. So yeah, I think it is a bit tricky to find a such document which covers both. But yeah, you get a general concept. I think yeah, that document will cover. I mean, the Udemy course will generally cover the basics, and then you'll go to AWS specific. I think that way it is very well articulated.
I think I have sent you guys a book also, right? There is a book also. I gave you guys a link. If you want, I'll send it to you again. I use that book for preparing the exam. Actually, I didn't have the Udemy that time, so I'll send you guys the link to the book.
Yeah. But generally, it took a while for me to understand this concepts. I think it is really. I mean, after realizing this, I see that it is how well they architected their products. So I think I'm really started appreciating AWS now. I mean, yeah, the more I learn, I really feel that it is well articulated. So
And being a leader, the rest of the people they know what to do now. That's what Google and Microsoft, everybody they just tweak a bit here and there, but concept wise they follow similar.
exactly, yeah.
One last thing, right? Like, so, Srini, you have been saying Google is copying AWS, but as far as I know, like Kubernetes is not a IaaS platform; it is a PaaS platform. It's PaaS, right? So, what is the like comparison here? I don't think there is any product which is
EKS,
equivalent to AWS.
EKS man, come on, 70% of Kubernetes is running in AWS. It's called EKS. It's very
Yeah.
popular.
That comes to actually running a web server within a VM. That's all it is. Yeah, that's all it is actually,
No,
right?
they
So
manage the they manage
okay,
the
we'll
control
talk about
plane.
that.
They manage the control plane also. We'll talk about it. It's very interesting.
Yeah,
And you
yeah.
know what? Since you brought the subject, they are the first guy implemented serverless Kubernetes for Gate. Even Google did not come out.
Mhm. Okay.
Hey, Sini, one question.
Yeah.
So when you start creating subnets, VPC, and then you start with IPv4, and then you find that your requirement has gone, and then now you want more address space for more servers. Can you just automatically convert the IPv4 to IPv6, or you have to start all over again?
That's a good question. I think when you configure itself, usually you specify both if you want. I don't know. I have to check that. Can you add it on top later? I have to check that. But one thing what they have done is, for example, initially you went with 16. Okay, that means you don't have too many bandwidth. Later you are expanding. They have then you can change it on the fly. So you can still use IPv4, but you can change the 16 to 24 to 16 easily. They have done that.
So that may be relatively easy because it's a 32-bit address space.
Yeah.
But when you go to IPv6, it's 128
Correct.
bit.
Yeah, that is why I don't know. I have to check.
Okay.
I'll check that.
Thanks.
Yeah, very good question. Even I also don't know the very good question, but yeah. Okay, I think let's logically break here. So I think the following week, I think we'll go through the VPC with I think
It's a great session.
yeah,
Yeah, it's great. And next week Sunday, man, not Saturday. Okay,
Sunday, is it?
same
Okay.
time.
Okay.
Yeah,
Okay.
I have another training from AWS, so I will attend that. So we'll do Sunday the same time.
Okay. Fine.
Okay.
Okay, guys.
Yeah. So,
Right.
yeah.
Good job.
Thanks a
Good
lot.
job.
Thank
Yeah.
you.
Thanks.
Thank you.
Thanks.
Thank you all. Thank you.